All right, let's say that I gave you this problem here. So we've got this triangle. We know a couple of the sides. We're given one angle. But I ask you to find the area of that triangle. Well, what I'd like you to do is I'd like you to pause the video real quick and take a shot at this one. And then after you've taken a shot at it, come back and see what you might have done in order to figure out what the area is. So go ahead and pause it. All right, after you tried this one, you probably thought about the fact that we know how to find the area of a triangle. We know that's going to be 1/2 the base times the height, but we didn't have all the information we needed. We did have probably a base that we could use. So 12 is probably a good value to use for the base. Where it got a little bit tricky was the height. So we've done enough of these where hopefully you thought about, well, I could draw the height in right here. From there, though, you might have got a little bit stuck unless you remembered our options, because we've got a right triangle there on the left-hand side. We know the angle is 40 degrees here. The height would be the opposite side. The 8 would be the hypotenuse. So really, we're looking at the sine of 40, where the opposite side, again, is h, and the hypotenuse is 8. So in order to find the height, I'd have to multiply both sides by 8. And so the height is really 8 times the sine of 40. So in order to find this area, I could actually plug in that to the calculator to get my answer. And so your answer should have been for this one approximately 30.85. And this was in inches, square inches. All right, so that method hopefully wasn't too bad. But it actually kind of leads into maybe a faster way of attacking a problem like this. So let's kind of note the information we had in this one. If we look at the information we started with, we really started with this side. We started with a side over here, and we had the angle that was in between those two sides. Or, if we noticed it, it's really back to everybody's favorite. This was a side angle side situation, where we had two sides and the angle in between. But how did we use those pieces? Well, if we go back to what we ended up with, we had half, because it was a triangle, of 12, which was one of those sides we were given, times 8, which was another side that we were given, times the sine of the angle that was in between. So in general, we have what I call the side angle side area formula. Which basically says, if I use that picture at least, the area would be equal to a half, because it is a triangle, times the two sides that you're given. So in our picture, it was B and C, times the sine of the angle that's in between those two. And so if I talk about the side angle side area method, this will always work if we're given two sides and the angle in between. It doesn't matter what kind of triangle we have, we can always use the two sides and the angle in between if we're given that information. And then we can use those by taking half of the two sides multiplied together times the sine of that angle. All right, well, how that's going to be helpful. Let's say that I was given this situation. This is actually number 47 from chapter 8. But I'm given this situation here where I have, first of all, a square, and I'm asked to find the area of the square. So if I look at this square here, they didn't give me much. They only gave me the distance from the vertex to the center of my square. They said that was 6. So somehow I got to use only that information to figure out what the area is. Well, notice they kind of gave me a picture here that's created with these 4 triangles. And when we talked about doing the reflections, we said, okay, well, if it's really going to be reflected to make this polygon, then these should be isosceles triangles. So that means that that value of 6 would be the same here as it was on the other side. Also, we said if it's really a regular polygon, when we look at these angles here in the middle, they're all going to add up to 360, but they should also all be the same. So 360 divided by 4 tells me this is actually a 90-degree angle. So if I were going to find the area of this, maybe one method would be this. I could say, all right, well, this is really a right triangle. The base is 6, and so is the height. And then I have 4 of those triangles. So if I were looking at the area of this one, I'm looking at an area of 72 square units. Well, that one wasn't too bad because we had a right triangle on the inside. Let's see if we can deal with this regular hexagon in the same manner. So if I were to create triangles just like we did a second ago, I'm going to end up creating 6 triangles that are all the same. Well, within those 6 triangles, we could find the angle here in the middle because we know it's 360 divided by, in this case, 6. So I know that's a 60-degree angle. I also know this should be an isosceles triangle, or else I wouldn't be able to make that regular polygon. So if I have a 60-degree angle, I know these two have to be the same because it's at least isosceles. Well, if I take 180 minus 60, that gets me to 120. And when I cut that in half, I find out that not only do I have an isosceles triangle, I actually have an equilateral triangle because all 3 angles are 60 degrees. Well, that's helpful because I know this side is 8, and that now tells me that both of these sides would be 8. This is where the side angle side area formula is going to help us out. Because notice in my picture, that means I now have 2 sides, and I have the angle in between those 2 sides. So to find the area of that triangle, I'm going to do half of the 2 sides that I know multiplied together times the sine of that angle that's in between. Now, keep in mind what our goal was, though. Our goal was to find the area of the entire hexagon. And right now, I'm just finding the area of one triangle. But the nice thing is all the triangles are the same. So once I find the area of one of these triangles, I can multiply it by 6, and that should now be the area of the entire regular polygon. So if we put all this in, let's see what our area is. We should end up with an area here of 166.28 square units. So using the idea of what we talked about the other day by taking isosceles triangles and creating these regular polygons, if I'm able to find the area of one of the triangles, I can then just multiply it by however many triangles I have. And how many triangles I have really should match how many sides that I have. And now that side angle side method might be a faster way to find the areas. All right, well, I'm going to have you try something here. I've got 2 regular polygons here. Notice they're given a little bit different information. In this picture here, they're given the distance from the center to the vertex. We're told that's 11. Over here, though, we've got the distance from the center straight down to that side. So in this one, you might think about, okay, well, how can that be helpful if I were to create this triangle? Over here on this one, we know that this distance is going to be the same there. But I'd like you to see if you can find out what the area is for both of those two regular polygons. So go ahead and pause the video and then come back and see how you did. All right, well, let's see how we might find the area of part A. Well, the nice thing is on part A here, I've got two of the sides. So if I can figure out what this angle is here in the middle, then I should be able to use my side angle side area method. Well, to find that, I'm going to think about what, really I'm going to draw in all these triangles, and they should all be the same. But they should also match how many sides we have. So let's see how many sides we had here. We had 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So if I take 360 and divide by 9, that should tell me what the angle measure is here. So 360 divided by 9 tells me I have 40 degrees. And so now I can use my side angle side area method. So I'm going to do half of the two sides I know, multiply together, times the sine of that angle that I just found. And in this case, we had 9 triangles, so I'm going to multiply that answer by 9. So if you did this one correctly, you would get an area of 349.998. So almost 350 square units. Well, let's see what happened over here. Well, over here, remember, they actually gave me the height. They told me the height was 5. We probably want to know how many sides we had, because again, that's going to tell me how many triangles I have. So if we look at our sides, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 sides. All right, well, if I have 10 sides, I can find that angle there at the top. So 360 divided by 10 tells me I have 36 degrees for that total angle up there. Well, I don't really have a side angle side situation going on right now, but I do have a right triangle. So let's think about the situation that I could maybe use to help me. So I know this height is 5. I know the entire angle is 36. So this would be half of that. That's 18, because again, remember, this is an isosceles triangle. So if I can somehow figure out how long this side is right here, or in this right triangle, this side right here, then I could use the side angle side method, because if I knew that one, I would know this one, and we already knew the angle in between those two. So I'm going to use that picture there, and I'm going to see if I can figure out how long that side is. Well, if we look at the picture, I've got the 18 degrees. 5 would be adjacent to that, and x would be the hypotenuse. So anytime we're using adjacent hypotenuse, we know we should be using cosine. So I'm going to do cosine of 18 and say that's really equal to 5 over x. So if I put that over 1, I have x times the cosine of 18. That's equal to 5. And I can divide by the cosine of 18. So 5 divided by the cosine of 18 is 5.26. All right, now we should have enough to find the area, because if this is 5.26 and this is 5.26, I can go back to my side angle side area method. So I can do half of those two 5.26s times the cosine of that angle we said was 36, and then we have 10 triangles. And so when I punch it all in, I get 111.92 square units. So that was one option that we could have done. Some of you might have figured out a way to find this side here. And that would be a good option as well, because then you'd have the base and you could go back to our traditional area formula of half the base times height. But a lot of the ones that we do here with regular polygons, creating those isosceles triangles, finding the area of one of those isosceles triangles, and then multiplying by how many sides we have, is going to be our fastest way to find the area. All right, let's see if you can apply it. This is problem number 52 from chapter 8. So if you need to look at the problem again, you could look that up. But here's the situation for 52. It says, recently your school ordered a stained glass window with the design of the school's mascot, which was the rodent. Your student body has decided that the shape of the window will be a regular octagon. So we're looking at 8 sides here. And that regular octagon is shown down there in the corner. To fit in the space, the window must have a radius of 2 feet. So notice that's marked in the picture as well. And when we talk about the radius of a regular polygon, it's the distance from the center to each vertex. Okay, a couple things here. First of all, on the first part, a major part of the cost of the window is the amount of glass used to make it. The more glass used, the more expensive the window. So your principal has turned to your class to determine, well, how much glass will the window need? So the first thing you got to do is figure out what the area is for that figure. Then, secondly, on part 2, the second part, they say the edge of the window will have a polished brass trim. Each foot of trim will cost $48.99. So how much will the trim cost? So we're kind of looking at 2 different situations. The first thing you want to figure out is, okay, what's the area of that figure? And then secondly, we're looking at the edge of the window. So essentially, we're on part 2, we're looking for, well, what's the perimeter of that figure? So again, I want you to work through this, so pause the video, and then come back and see what you might have done to attack this one. All right, let's start with area here. Well, we said we had 8 sides. So that means we've got 8 triangles. They're all isosceles. I'm going to find that middle angle by taking 360 divided by 8. So that tells me I have a 45-degree angle. And now I'm going to use my side angle side area method. So I'm going to do half the 2 sides that I know times the sine of the angle in between those 2 sides. And we said it was an octagon, so we have 8 sides. So when I punch that in, I'll know what the area is for my figure. And so I got 11.31. This time it was feet, so square feet. All right, the second part is a little tougher. We want to find the perimeter first of all, because they said they want to know how much it was going to cost for the trim. So I basically want to figure out what this is right here. Well, I don't have a right triangle. I could create one if I wanted to. But we have other options whenever we don't have a right triangle. One of those is the law of sines. Well, the law of sines, remember, we need an angle and the side across from it. Well, to start with, I've got an angle, but I don't know the side across from it. But I could find those 2 other angles because it's an isosceles triangle. So if I take 45 away from 180, and then I cut that in half, that'll tell me what each of those 2 angles are. So each of those angles are 67.5. That would be here and here. So now I could do the law of sines, because I can say, well, the sine of 67.5 over its opposite side, which is 2, would be equal to the sine of 45 over its opposite side, which is what we're missing. So we can do our cross multiplying and figure out what our value is here. And when we do that, you should get that this side was 1.53. Now, some of you might have been saying, well, I've got two sides and an angle in between. Couldn't I have used law of cosines? Yeah, that would have been fine as well. Usually law of sines is a little faster, but nothing wrong with using law of cosines there. Now, remember, that's just one side, though. So we still have to multiply that by 8. We got 8 of those. So the entire thing has a perimeter of approximately 12.25. But the problem wanted us to figure out the cost. So they said that each foot, we had 12.25 feet here, each foot was going to cost $48.99. So I've got to take this now and I've got to multiply that by $48.99. So when the bill comes around, it's going to cost us $600.13 approximately. All right, so finding the area of a regular polygon is kind of the big idea here. Using those facts that we've talked about in the past with the angle that we can find by dividing 360 by how many sides we have is helpful. And now we have that extra formula that might be helpful as well, where we use the side angle side area.